Hey guys, welcome to our second lecture on reactions. We are going to be taking notes on page 6 of your packets. And today we're going to take a look at how we are getting those coefficients that we've been seeing in those balanced chemical equations that we were writing from sentences or going from sentences to formulas or, equations back to sentences. Those coefficients are put there in order to balance, that's how we say it, balance the chemical equation. Now, what we mean by that is we are accounting for all of the atoms that appear in the reaction because atoms cannot be created or destroyed. So that's our law of conservation of matter. The atoms that we have at the beginning of the reaction have to appear at the end of the reaction. Now, they might not be in the same compound. They might now be in an elemental state. But the numbers of atoms that appear on the left have to also appear on the right. We can't just lose an atom of oxygen in the reaction. And so a good balanced equation will have the same numbers of atoms of each element on both sides. Go ahead and pause if you need to finish writing those out. This next part you do not need to write out, but I did want to walk you guys through a little example here. Imagine that our reaction is a carbon atom, which you see here, reacting with a diatomic molecule of oxygen. So carbon reacts with oxygen to form carbon monoxide. Now, we know that that's possible. We know that carbon monoxide is a compound that exists and it's formed from carbon and oxygen. But the problem is if we look at this reaction, we see one carbon atom on the left and one carbon atom on the right. But we see two atoms of oxygen on the left and only one atom of oxygen on the right. And that doesn't make sense. We can't just throw away that oxygen atom and pretend that it was never there. So in order for this reaction to take place, we need to represent it appropriately with some coefficients out in front. We would need another oxygen in our product. But I cannot change this to CO2 because you guys know carbon monoxide and carbon dioxide are two very different substances with different properties. That was not the reaction that was taking place. It wasn't the production of CO2. It was the production of carbon monoxide. So we can't just put a subscript of a 2 out here. That's not how we balance equations. We balance equations with coefficients out in front to show us how many of each thing we have. So this balanced equation would require that I need to make 2 molecules of carbon monoxide. And so now my number of oxygens is correct. I have 2 oxygens on the right. And I have 2 oxygens on the left. But now I have 2 carbon atoms on the right, and I only have 1 carbon atom on the left. But I can just solve that problem by bringing in another carbon atom. So in order for this reaction to occur, I need 2 atoms of carbon. I need 1 molecule of diatomic oxygen. And in that process, I will produce 2 molecules of carbon monoxide. And there is your balanced equation. 2 carbons plus 1 molecule of oxygen makes 2 molecules of carbon monoxide. I just realized I totally could have done this demo for you with my molecular models, which is what I would have done in the classroom. Oh, you guys don't need to see me. All sweaty after my run. I'll just keep going with the PowerPoint as is. I'll spare you. Okay, so let's put together some steps for balancing and some, helpful tips. Most of you maybe remember how to do this from middle school, so, bear with me as we go through these rules. If you don't feel like you need the rules, you can skip forward to the practice problems. Okay, so rules for balancing. Step number 1 is to write an unbalanced chemical equation. I usually like to leave myself little lines out in front of each of my elements and compounds in the reaction to remind myself that I need to go ahead and put some coefficients in there. And then you're going to see me count up the atoms on each side. So I'm going to look at how many hydrogens are on the left versus how many hydrogens are on the right. And then we're going to plop some coefficients in there to make those numbers equal. Now, when you put a coefficient in front of a substance, the coefficient times whatever subscript is next to that atom will equal your total number of atoms. So you're going to have to make sure you update your counts every time you add a coefficient. If for whatever reason you end up with, let's say you ended up with 2, 4, 2 as your coefficients. If you can then go and reduce that to 1, 2, 1, go ahead and reduce. So sometimes just for whatever reason as you're going through, sometimes you end up with bigger coefficients than you need. We always reduce it to our lowest coefficients. And then double check your work. Go ahead and pause there if you need to. I'm going to move on to some helpful tips. Now, these helpful tips are going to make more sense once we get into our examples. Balance one element at a time. Like when you're counting up your hydrogens, count up your hydrogens on your left, and then count up your hydrogens on the right. So kind of work with one element at a time, and I often just move left to right through my reaction. Like I said before, anytime you add a coefficient, make sure you update the count of all of the atoms that that coefficient applies to. This is going to be very important in our combustion reaction example, so you'll see what I mean when we get to it. If an element appears more than once per side, so for example, if your reaction produces carbon dioxide and water, you've got oxygen in the carbon dioxide and you have the oxygen in the water. You have to account for all of that oxygen. So that can be a little bit tricky. So just save elements like that, elements that appear more than once per side, save them till the end. Balance polyatomic ions as units. In other words, if you're looking at a substance that has sulfate in it, instead of balancing sulfurs and oxygens, just put some parentheses around that sulfate if they're not already there, and think of it as a unit. So if you have 2 sulfates on the left, you're going to need 2 sulfates on the right. Now, of course, you can only do that if the polyatomic ion stays together in the reaction and appears as that polyatomic ion both on the left side and on the right side. There are some rare instances where those polyatomic ions break apart and you can't balance it that way. But if they're together on the left and on the right, it saves you some time. Again, go ahead and pause if you need a little more time to write those out. And finally, for our never evers, I know these seem silly, but I promise you I've seen students do it. So that's why I have this never ever in this fiery orange color. Never ever change a subscript. Okay, the subscript tells you what the substance is. So we cannot change subscripts to make our balancing work out. Okay, H2O is very different than H2O2. So this is water, this is hydrogen peroxide. So if you needed more oxygens in your compound, you need to put a coefficient out in front. You cannot add a subscript. And the other thing you can never do is you can never smush your coefficient in the middle of a chemical formula. If you need, 2 chlorines, you have to put the 2 out in front of the whole thing. You cannot put the 2 in front of just the chloride ion. Yes, that means now you have 2 sodiums and 2 chlorines, and you're just going to have to deal with that by putting coefficients wherever else you need to in your balanced equation. Let's do a couple of examples together. And I believe in the CP packet, I left space for you guys to do this on the next page, and in the honors packet, I didn't. I don't know why. Honors people, if you want to practice these on a separate sheet of paper, if you can squish them over on the side of page 6, go for it. Let's do some together. Go ahead and pause the screen right here and write these reactions out, and make sure you include your spaces. Oopsies. Make sure you include your spaces to add your coefficients. And then go ahead and unpause once you've written these out so we can talk through how to balance these together. Pay attention when you're writing them to get all your subscripts correct. Okay, so we're gonna balance one element at a time. We're gonna do these counts in our head. Some people write them out. I think you can do them in your head. So I look here, 1 potassium on the left and 1 potassium on the right. So that's balanced. 1 chlorine on the left, 1 chlorine on the right. And so that's balanced. 3 oxygens on the left and 2 oxygens on the right. Now, we need to find a least common multiple here, right? So I need to make 3 and 2 equal to one another. Well, how do we do that? We need to find that least common multiple, which is 6. So how am I going to get each of these oxygens to a total of 6? Well, I'm going to put a 3 out in front of this oxygen. 3 times 2 is 6 oxygens on the right. And over here on the left, I'm going to put a 2 out in front. Now I have 2 times 3. Now I have 6 oxygens here on the left. But when I put that coefficient of a 2 out in front, that just doubled my potassiums and doubled my chlorines. So now I got to go back to the right-hand side of my reaction. If I have 2 potassiums on the left, I need 2 potassiums on the right. I have 2 chlorines on the left and 2 chlorines on the right. So you just slowly go back and forth, counting up how many of each atom you have and add those coefficients to make them equal. Let's do another one. I have 2 hydrogen atoms on the left and only 1 on the right. So I'm going to put a 2 out in front. I don't know why it's so high up. 2 hydrogens on the right. When I put that 2 out in front there, it also made 2 chlorines on the right, which how convenient for me because I have 2 chlorines on the left. And now everything is balanced. You can put these 1s in there if you want to, if it makes you feel better, but 1s are generally understood and not written in. Let's go down here to my third example. I have 1 iron on the left and 1 iron on the right. I have 3 chlorines on the left and only 1 chlorine on the right. So I'm going to go ahead and pop a 3 out in front there. That just gave me 3 potassiums on the right, and I only have 1 potassium here on the left. So I'm going to put a 3 out in front to make my potassiums equal. And now I have 3 hydroxides. Here's where I was talking about keeping those polyatomic ions together in your head. See how it's OH here on the left and it's OH here on the right? If you've got hydroxides on the left and the right, you can just balance them as a little unit. So this 3 out in front here means I have 3 hydroxides. And this subscript of a 3 means I have 3 hydroxides in my compound. So 3 hydroxides on the left and 3 hydroxides on the right. And I'm balanced. Last one. 1 potassium on the left, 1 potassium on the right, 1 chlorine on the left, 2 chlorines on the right. So I'm going to pop a 2 over here in front of my potassium chloride. Now when I did that, yes, it made my chlorines equal, but now it made my potassiums too. My potassiums were already balanced. So now I'm going to need a 2 out in front over here to make my potassiums balanced. Now here are my nitrates. Remember, these are a polyatomic ion. This 2 out in front here means I have 2 nitrates on the right. And right now I only have 1 nitrate unit on the left. So I'm going to need a 2 out in front here. And by doing that, now I have 2 mercury atoms on the left. Oh, look, I have 2 mercury atoms on the right. And it's balanced. Now there's one more example that I definitely want to go through with you guys, and I don't have it in the PowerPoint, so we're going to switch over to some smooth draw here. I want to do a combustion reaction with you. So what we're going to do is I'm going to do the first 4 examples on pages 7 if you're in the honors packet, or page 8 if you're in the CP packet. Let's go ahead and do those together on my smooth draw. Okay, so these are the 4 example problems at the top of your first page of practice. Bear with me for 1 second. Get my setup. Okay, here we go. 1 sodium on the left, 1 sodium on the right, 2 iodines on the left, only 1 iodine on the right, so I need a 2 out in front here. Now I have 2 sodiums on the right, and so I need 2 sodiums. All of a sudden my pen's not working. That's interesting. Oh my gosh, now it's acting really crazy. All right, hang on, I'm gonna have to reset my thing, you guys. I'm gonna pause this recording.